Alright, hello Year 7s, welcome to my next video. Here we're looking at 6G. It's on page 357, and we're looking at converting fractions to decimals and decimals to fractions. The first question is this: convert the following decimals here to fractions in their simplest form. First of all, I just want to show you a couple of things. When we're looking at decimals, they're numbers that exist after the decimal point. They're what we call decimal numbers. If we were only to look at the numbers inside this red box, you would say it's 0.1. Let's just ignore those numbers. Pretend they don't exist right now. Just 0.1. If you ever have just one number after the decimal, so this 1 here, we call that 1 because the number's 1, and then you write or say tenth. When there's one number after the decimal, it's a tenth. So that is 1/10. In this case, ignoring these numbers, if you just had this number, 0.12, you can also say 12, but not tenths now. The next one higher, hundredths. 12 hundredths. And again, this would now be 123 thousandths. And we can keep going forever and ever. So let's have a look at this first one here. Convert this one to fraction. Well, first of all, let's recognize what number it is. It is 0.317, or another way of saying it is 317 thousandths. I know it's thousandths because there's 3 numbers after the decimal, okay? So the way we convert this to fraction is by doing this. 317, instead of writing thousandths, no, you don't do that for this question. We divide, so we turn it into a fraction, and on the bottom goes 1,000, because this is 317 thousandths, right? There's 3 zeros, thousandths. So let's do the second one, see if you can get into a bit of a rhythm here. The next one's 0.49, right? So we write the whole number, just 49. We just write these two numbers. And then we write on the bottom, well, are they 49 thousandths? No. There's only 2 numbers here. So they are tenths. So 49, sorry, not tenths, I beg your pardon, hundredths. So 49 hundredths. Next question. This looks a little bit different. The difference is, well, in part I and part II, or part 2, they had 0 at the start. But in this case, we still have a decimal number here, but then we also have a whole number. We treat the whole number by just writing the whole number like that, and then we do decimal 45 the same way we did decimal 49 over here, right? So in this case, it would be 12 and 45 hundredths. 12 and 45 hundredths. And so over here, you would do something very similar. You would write 9, because the whole number is 9, there are 9. But then there's 0.25, which is 25 hundredths. How did I know there were hundredths? Because there are 2 numbers after the decimal here. Okay. I'm going to go ahead and do question 2. So question 2. State whether each of the following are true or false. Does 0.333 and these 3 dots here mean that the 333 keeps on going forever? Is that the same as this number? Well, no, because the 3 stops here. There's not another 3 and a 3. So what that means is the next number here would actually just be 0 and 0 and 0. So the answer for this question is false. I'm not going to give all these questions away. I'm going to do D, right below it. Let's have a look at this one. 1.7272, is that the same as 1.72? Oh, what's this dot here? This dot means recurring. It means that the 2 here actually repeats forever. And is that the same then as this number here, 1.727272? No, it's not going to be the same, isn't it? So that's false. All right, let's go ahead and convert, question 4, these fractions to decimals. How do you convert a fraction to a decimal? Well, before I show you, I just want to show you that there is an example here that is related to these questions. I wonder if we have example 19a. I'm sorry if we don't, but I think we do. There it is here. 19a. And it's going to give us an example about how to convert this fraction to a decimal. There's not too much to show with this solution. And the reason why is because, well, in this question, 17 hundredths, all we do is the invisible decimal that exists at the end of every whole number just goes back 2 positions. 1, 2. Why did I go back 2 positions? I did that because there are 2 zeros. The number of zeros that we are dividing by tells me how many places back I go. Let's try that. So 4a. Let's convert 7/10 to a decimal. How many zeros are on our bottom number here? Just 1 0. That means the invisible decimal that occurs at the end of every whole number goes back 1 position. And so it would look like this. I'm going to delete this decimal here, and I'll replace it with the decimal here. And so the answer is equal to, put a 0 there, 0.7. Let's do the next one, 9/10. Well, we're dividing by 10, which means there's only 1 0 here, which means the decimal at the end of 9 goes back there, 0.9. C, bit trickier. We're dividing by 100 this time, so the invisible decimal goes back 2 spaces. So the answer will be 0.31. I'm going to let you finish these questions off and refer to the solutions that was attached in the original email sent to you all to confirm your questions. If you have any other questions, if you get stuck on anything, email me, or you can basically email me, and I'll try and reply within the same day. All right, thanks, Year 7s. Have a good afternoon.